We are the KU Robotics organization. We are a multidisciplinary group that provides hands-on experiences to our members. We're open to all majors and all experience levels. And we are an umbrella group that houses many small projects under us, where the executive group's goal is to basically provide funding and minimize the barriers to getting immediately started on projects.
So here at Kakuro, you can see that we do a lot of 3D printing. So the main way of, or the most common way of 3D printing here is fused filament fabrication, which is just a fancy way of saying that they get some plastic and push it together into a coherent shape. We primarily use PLA, which stands for polylactic acid, which is made from cornstarch, bioplastic, and it is compostable as long as it is done in an industrial setting. You cannot put it in a backyard compost and compost it that way. So you can see our plastics come in a wide array of colors. See all the benchy and Moai statues, tiki torches, and our articulated starfish, as well as some other projects. So 3D printing, it's useful for making quick parts that you need to test in the real world. So instead of using simulations and other guesswork, I guess, you could actually get a physical part and test if it works or not. Another benefit of 3D printing is it just looks nice. You could make nice looking parts and just little trinkets and whatnot, and that's pretty much 3D printing in a nutshell.
My name is Chauncey Hester, and I'm going to be talking about the Wizard Chess. It basically is one of our more involved projects where it's built basically in 3 parts. There is the part that is using Alexa AWS IoT to communicate over the internet to get chess piece moves. So I could say like move A1 to A5, and it will grab, or it will send that information to the Raspberry Pi. And then there is the mid-level control where the Raspberry Pi is listening for the Alexa to talk, and then it interprets that information and sends it into a chess engine to verify that it's a valid move. And then there is the low-level control where it specifically interfaces with a 3D printer board in order to control 2-stepper motors using just G-code. Once the 3D printer has received the command, the Raspberry Pi waits for a move to complete and then turns on an electromagnet so it can grab the chess pieces and move them around. And that is Wizard Chess.
Hello, my name is Caleb, and I was helping work on the Nerf Dart turret. And how it works is you load in about 6 or 7 Nerf darts, and you are able to control how it aims. It has a laser pointer that points to which direction you want to shoot, and it shoots a Nerf dart straight ahead, whichever direction that is. So we've been working on that project for a little bit now, and it's been a lot of fun. We control it by using a software on the Raspberry Pi. We plug it in with a micro USB, and we're able to control the direction that it goes. It can turn left and right, and it can turn up and down, and it pushes out with the motors in front, pushes out the Nerf darts in whichever direction you choose.
Hi, I'm Tiger with KU Robotics, and I built a physics simulation in Unity game engine using this holographic 3D portrait, the looking glass portrait, and an ultraleap motion controller. So the controller has infrared rays that hit your hand to detect it, and then it sends that data over USB to my computer, which the portrait is also plugged in. And so it's able to track both hands. And I've added detection utilities for both collision and for pinching and picking up the cubes. That was quite a challenge. And there's also a reset button to reload the scene after you're done hitting all the cubes. In the future, I also intended to add a turntable so that you could rotate the 3D model within the portrait and some other things.
So this robot is called XBV4. It's one of our attempts for accommodating for the fact that Expo is hybrid and virtual this year, where we made it so that anyone in the world can theoretically control this robot just over the internet, and it's just controlled using keyboard and mouse. And it spawns a window that you can just control. It's a very simple GUI that just has arrow keys, control WASD. This robot was originally controlled using a PlayStation 4 controller and just using Bluetooth. We just modified the code to make it able to control just via a protocol called SSH, which any computer can use using either PuTTY, or if you're on a Linux computer, you just open the terminal. It's just controlled using a Raspberry Pi that's talking to two motor controllers that have ESCs, which can drive. What else to say?
ESCs that can drive.
ESCs, they drive motors. It goes zoom.
Go for it.
Oh, it's gonna be really weird. It's gonna like jump cut to it just being slightly higher now.
Go for it. I mean, I don't know where I was.
Yeah, it's fine. And then the way that students that are connecting remotely can see it is that we have a phone that will be connected to our Zoom call that will just have a first-person view of the robot. And that's it.
That hurts. Wait, do it again.
Do it again.
I want to see if I can get like video of it coming right at me.
Oh, you didn't get a video of it?
Not right at me. God, we're just a bunch of children, but that's what robotics is about, right?